This video is in response to a question on the section 4.1 homework. 4.1 is scatter diagrams and correlations, and this is problem number 12 from the homework. Okay, so I'm not going to do this whole problem, just parts A and B. They actually use two different calculation processes in StatCrunch, so I will do both of those. So, researchers wondered whether the size of a person's brain was related to the individual's mental capacity. They selected a sample of 5 females and 5 males and measured their MRI counts and IQ scores. The data is reported to the right. So here's the data, and the first thing that they ask us to do is make a scatter plot. So I'm going to open StatCrunch here. And here's the data. Now, they want a scatter plot of everybody, and so we actually need to make a new column that is both, so that we can make the scatter plot of both. So I'm going to copy and copy. So I'm just doing Control-C and then Control-V. And then to make this scatter plot, I'll just do a graph and choose scatter plot. And the X variable, so it says, it actually depends on how they write the question. So the X variable says, treat the MRI count as the explanatory variable, so that's the X for explanatory, and IQ as the response variable, so response is the Y. So since the MRI is our explanatory variable, that goes on the X, and IQ goes on the Y, and then we're just going to go ahead and compute. Now, if we look at the graphs that they provide us, the scales on those graphs are a little bit different, and so if you want to make your graph match, you can go in here. So for instance, this graph goes from 130 to 145, so I could say make my y-axis 130 to 145 instead. And then you get something that looks more like it. But so the graph, you just look and compare the graphs and pick one. So that's part A. Part B says compute the linear correlation coefficient between MRI count and IQ. And we're trying to figure out if they are linearly related. So you have to actually use a different calculator in StatLab to do that. And we need to go to Stat, Summary Stats, Correlation. So we're still doing both. And so the columns that we want to figure out the correlation coefficient are the ones with both. And so we'll go ahead and say compute. And here is the correlation coefficient between the MRI and the IQ for both the women and the men put together. So it's 0.71, we have to go to 3 decimal places, 0.714. Now the question is, does that mean they are linearly correlated or not? And so in order to determine that, we need to look at these critical value table here. And so N is how many people are in the study, and there were 5 women and 5 men, right? So we had, our N is 10, and so when our N is 10, the correlation coefficient minimum for them to be linearly correlated is 0.632. So since this is bigger than 0.632, remember, if it's equal to 1, it's exactly on a line. So since this is bigger than 0.632, we say they are linearly correlated when we put the women and the men together. So 0.714, so I would go in here and I would say yes, since the correlation coefficient is 0.714. So there you go. I hope this helps.